Examples on chain rule. What I'm going to do first is just review with you guys just to make sure you understand product quotient and power rule. Do a few examples. I encourage you guys to hit pause and I will walk through how to do some of these examples with you, including G is going to be one of them, I is going to be another one, and then we're going to move on to some chain rule problems. So as a refresher, why don't you guys hit pause and then do G. So f prime of x here, power rule on the first one, 2 times 3 is 6, deduct the squared by 1, so then you have 6x minus 2 times the exponent, so minus 2. X to the 0 power is just 1, so whenever you're taking a derivative with 1 as the exponent, you're left with a constant. And then the derivative of cosine is negative sine of x. Okay, so moving on to I, you notice that you have a quotient of 2 functions. So what I'm going to do is apply the quotient rule. The derivative of f, or f prime of x, is low, d high, derivative of e to the x is itself, minus high, which is e to the x. The derivative of the bottom is cosine of x, over what's below squared. So sine of x quantity squared. And because we're not trying to prove anything, this is going to be our answer. Let's go ahead and try J as well. Why don't you guys try doing J on your own and double check your answer? Okay, for J, the derivative would be low, x squared, times low d high. So the derivative of tangent of x is secant squared of x minus high tangent of x d low, the derivative of the bottom, so 2x all over what's below squared, so x squared squared. And once again, we can leave our answer as such. Okay, so now we're going to move into some how do we do these chain rule problems. So I'm going to go through a few examples with you. So we're going to find f prime of x. And we're noticing as you scan through the problems that all of these problems are composite functions. So we're going to do the same thing and say that pink is mommy and that blue is baby. So mommy and baby, and highlight as we go. So in this case, the baby is x squared minus 4. In the next example, it's 3x. In the one after that, we'll come back to it possibly, but if I move the exponent out as secant of x cubed, it's going to be secant of x. The baby function for f would be x to the 7th minus 3x. And then the inside function for g is cotangent of x. Okay, so now we're going to do problem C by highlighting the mommy function next. So the mommy function is sine of x. And then let's go ahead and do the problem. Okay, so the rule was we take the, and actually I'll write out the formal rule for you guys here. So if I have g of f of x being the function, so let's define a third function h of x, and it's a composite function g of f of x, then the derivative of that function is take the derivative of the mommy function, leaving the baby alone, and then times the derivative of the baby function. So this is a chain rule. You have 1 generation, 2 generations. So in this case, f prime of x is the derivative of sine, take the derivative of the mommy function, the outside, leaving the baby alone, so leaving x squared minus 4 alone, and then my second chain, so this is chain 1, my second chain would be the derivative of x squared minus 4, which is 2x. The negative 4, the derivative of any constant is just 0, and that's our answer. Okay, for part D, our mommy function is, okay, this is kind of tricky here. Our mommy function is cosine of x. So if the inside function is 3x and the mommy function is cosine of x, what do we do with the 2? Well, guess what, you guys? We have a third generation in this household. This is a multi-generational household. This is the, let's call it the grandma function. Okay, and so our grandma function here is the squared. So if I were to rewrite this, it might make it a little bit more clear. You've got the baby function 3x inside the mommy function cosine of x, who are both inside the grandma function, which is 2. We end up having a baby function being defined as 3x because that's not just plain old x, it's something x. So that is considered technically more complicated than just a traditional x that you see. So anything beyond an x, we're going to call it a baby function. So here, we're going to take the derivative of let's just say like the older generation goes first. In this case, the grandma goes first. So the grandma's a power rule. She's just to leave mommy and baby alone to the first power. And then a 3-generational chain rule will have 3 chains to it. So you took the derivative of the grandma, leaving mommy and baby alone. Now the derivative of the mommy is negative sine of 3x, leave the baby alone. And then now the third chain is times the derivative of the baby function, which is just 3. And that, you guys, is the answer. All right, so with part E, how many generations do we think this is? Well, we have that secant of x is on the inside, and then that the mommy function is the cubed. And so when we rewrite this, it might become a little bit more clear. Secant of x to the third power. And so because this is just plain x, we don't have a third generation there. There's no chain to that because the derivative of x is just 1. So derivative-wise, f prime of x is the derivative of the mommy, which is the chain rule or the power rule. Bring the 3 down, deduct by 1, and then now times the derivative of secant of x, which is secant of x, secant of x, tangent of x. And then that's it. So 2 generations, 2 chains. And then finally, we have our f, which looks like something you guys could do quotient rule with, but I prefer chain rule myself just because I think chain rule is kind of fun and a little bit less intimidating than the quotient rule in terms of the number of terms you have. So you have 4, and you bring, in order to use the chain rule, we're going to bring x to the 0.7 minus 3x to the negative 5th power. We're going to bring the denominator up, make the exponent negative, and now apply the chain rule. So here we have our baby function. Our baby function is inside. And then we have our mommy function being the negative 5 and the 4. So when we take the derivative, we we take the derivative of the mommy first. So 4 times negative 5 is negative 20. X to 0.7 minus 3x. And then minus 1 from negative 5 is negative 6. And then times the derivative of the baby function, which is 0.7 power rule, x to the negative 0.3 minus 3. And that's it. So 2 chain rule, we have mommy and baby. And then finally, what do we have here? How many functions do you guys think how many generations do we have here? So we have, on this, we have the cotangent of x being the baby function. We have the mommy function being the square root of x. And then finally, we have the grandma function being tangent of x. So remember the derivative of the grandma first. So we have f prime of x is equal to the derivative of tangent is secant squared. So secant squared of leave the mommy and baby alone. So square root of cotangent of x times the derivative of the mommy leaving the baby alone. So 1/2 cotangent of x, leave the baby alone, to the negative 1/2, and then times the derivative of the baby, which is cotangent of x. And that is negative cosecant squared of x.